Hello and welcome. Today's goal of this lecture. In my previous video, I had seen more videos about complex differentiability and Cauchy-Riemann equation. Today's goal of this lecture. Today I will see some exercise for use of complex differentiability and Cauchy-Riemann equation. This is our today's goal of this lecture. At first, I will highly recommend you, if you don't see my previous video about complex differentiability and Cauchy-Riemann equation, I had discussed at least 3 or 4 videos about complex differentiability and Cauchy-Riemann equation. If you don't see, at first see this video. Then to understand today's video would be very easy. Okay. First example, the complex plane. So fz equal to obviously uxy plus ivxy, and here given f prime z. If f prime z equal to 0, then obviously f prime z means this is equal to uxx comma y plus ivxx comma y. If we differentiate with respect to x, similarly, if we differentiate with respect to y, then f prime z would be uyxy plus ivyxy. Then f prime z equal to 0, that imply uxxy equal to 0, vxxy equal to 0, uyxy equal to 0, and vyxy equal to 0. And ux xy equal to 0 along x-axis, move u same, and uyxy equal to 0 along y-axis, move v is same. Here u is same. That means since uxy equal to 0 along y-axis, move, that means u is same, and similarly y equal to 0 along y-axis, move v equal to c same. Therefore, that imply uxy equal to constant c. And here important thing, obviously the domain D is connected. When D is not connected, consider D equal to mod z less than 1 union mod z greater than 2. That means consider this domain. And notice obviously this domain is disconnected set. And consider the function is such type fz equal to 2 if mod z less than 1 and fz equal to 5 if mod z greater than 2. And obviously in this domain a prime z equal to 0 if mod z less than 1 and 0 if mod z greater than 2. Therefore, notice here a prime z is 0 in this domain, but the function is not constant function, and the function not be constant because here our given domain D is not connected. So a prime z equal to 0, that imply the function fz is constant in this domain when the domain D is connected. I hope my all viewers have understood this is clearly. Okay? Oh well. Next exercise. If real part of fz is constant and f is analytic in a domain D, that imply f is constant. This exercise also very easy type exercise. Here given real fz equal to constant and real fz equal to constant, that imply obviously u equal to constant, and u equal to constant means ux equal to uy equal to 0, and since ux equal to uy equal to 0, so by CR equation we can tell Vx equal to Vy equal to 0. Therefore, since ux equal to uy equal to 0 and Vx equal to Vy equal to 0, that means obviously u equal to constant and v equal to constant. Since u and v both constant, that means fz equal to u plus iv, this is constant. That means f is constant. Similarly, if imaginary of fz is constant, that imply f is constant. Similar. And this type of exercise actually very important for any competitive exam, also for higher study. Okay? OL. Another type of exercise. If modulus of fz is constant in a domain D, obviously D is connected set, and modulus of fz is constant means square root of u square plus v square equal to c1, that imply u square plus v square equal to c2. If this is constant, then that imply fz is constant in a domain D. For this, since our equation is u square plus v square equal to c2, differentiate with respect to x, then that imply 2u ux plus 2v vx equal to 0, and differentiate with respect to y, that imply 2u uy plus 2v vy equal to 0. Now just by Cauchy-Riemann equation we can write this as CR equation. We can write this equation as u ux minus v uy equal to 0, then u uy plus v vy equal to 0. Sorry, vux equal to 0. And notice, since the equation is homogeneous equation, determinant u minus v uv, this determinant is, just write it as ux, so this would be v u, this determinant would be u square plus v square, which is not equal to 0 since this is the square term, and this is the homogeneous equation. Since determinant is not equal to 0, that means the solution is u equal to v equal to 0. That means since u equal to v equal to 0, that means the equation is fz equal to 0 equation. I hope my all viewers have understood this is okay. Well, therefore, if mod fz is constant in the domain D, that means that imply fz is constant in the domain D. I hope my all viewers have understood the proof. Okay. Well, next exercise of CR equation is, if f and f bar both analytic in a domain D, then that imply the function f is constant. This is because suppose f and f bar are analytic in a domain D, where f is uxy plus ivxy and f bar is u minus iv, and u minus iv means u plus I times minus b. And since f is analytic, that means obviously this satisfies the CR equation, that means del u del x equal to del v del y and del u del y equal to minus del v del x. And here given f and f bar both analytic, since f bar is also analytic, that means it is also satisfied the CR equation. That means here del u del x equal to, since here b equal to minus v, so del u del x equal to minus del v del y and del u del y equal to del v del x. Now compare these two equations, then I will get del v del y equal to minus del v del y and minus del v del x equal to del v del x. That imply by this equation, that imply del v del y equal to 0, and from this equation this imply del v del x equal to 0. Since del v del y equal to 0 and del v del x equal to 0, that means since these both part 0, that means del u del x and del u del y both are equal 0. Since both are equal 0, del u del x, del u del y, del v del x, del v del y all equal 0, that means obviously u equal to v equal to 0, that means fz equal to 0 function, which is constant function. That means if f and f bar both are analytic in a domain D, then that imply obviously the function f is constant. Our next exercise, if f, g are two analytic functions in a domain D whose derivatives are identical, then that imply f equal to g plus constant. Here the derivative are identical, that means f prime equal to z prime and f prime equal to z prime, that imply f minus z prime equal to 0, and f minus z prime equal to 0, that means f minus z equal to constant. We all of us know this, a few minutes ago I have seen, if f prime equal to 0, that imply the function f is constant, that imply f equal to c plus constant. I hope my all viewers have understood this proof, and this type of proof actually very important for any competitive exam. Okay. Next I will see what is the complex integration. Till now I have seen the complex derivative. Now I will see what is the complex integration. Complex analysis, complex integral is either curve integral or line integral or contour integral. In a real variable, line integral means the path integration of definite integral, integration a to b fx dx is always along the x-axis from x equal to a to x equal to b. But in the complex function fz, the path of definite integral integration a to b fz dz can be along the curve from z equal to a to z equal to b. Obviously z equal to x plus iy, that means dz equal to dx plus I dy. Here not from x a to b, here fz along the path. If y equal to 0, then dz equal to dx, and if x equal to 0, then dz equal to I dy. From 1, 2 and 3, the direction of dz are different. Its values depend upon the path, because here the line integral means along the path or curve of integration, but the value of integral from a to b remains same along any regular curve from a to b. Since in real analysis here, if we consider here z1 and here z2, then this is the distance, but in complex analysis, if we consider here z1 and z2, then this would be such type of curve or such type of curve. So if fz is continuous on a directed smooth curve gamma and z equal to zt, here zt is the parametrization of gamma, where t lies between a to b, then integration gamma fz dz equal to integration a to b fz t z prime t dt. This is the parametrization of gamma on this interval AB. This is actually the complex integration, and this is called the contour integral. And if a curve gamma with parameter interval AB is closed if gamma A equal to gamma B, that means if the initial point is equal to final point, then the curve is called closed curve, and a curve is called simple if gamma t1 not equal to gamma t2 unless t1 equal to t2. And this is the picture. Here t1 equal to t2, notice, but gamma t1 equal to, at the point t1 equal to t2, gamma t1 equal to gamma t2. That means the curve is intersect itself, so the curve is not simple. Consider some parametrization curve. If we consider this straight line z1 to z2, then the parametrization curve would be zt equal to z1 plus t times z2 minus z1, where t lies between 0 to 1. And if we consider this type of circle where z1 equal to z2 here, and here the center z0, then the parametrization curve is zt equal to z0 plus r e to the power it, where t lies between 0 to 2 pi. And if we consider this type of circle, here z0, then parametrization curve would be same type, but here t lies between 0 to pi. I hope my all viewers have understood how the parametrization curve. Okay, for example, if we consider gamma, which is defined from real line closed interval AB to complex number, here closed interval AB to complex number, so the graph would be such type of curve gamma A, gamma B. Then if we consider the map gamma from AB to complex number. Then integration A to B gamma t dt would be, and which is equal to integration A to B real part of gamma t dt plus I integration A to B imaginary part of gamma t dt. And this is actually ordinary Riemann integral in real number. If we consider the interval 0 to pi to complex number, then the mapping would be gamma t equal to e to the power it. Would be such type 0 to 2 pi to the map is such type of circle e to the power it, where the integration is integration 0 to 2 pi e to the power it dt, which is equal to 0 to 2 pi cos t dt plus 0 to 2 pi sin t dt. Just integrate it, then you will easily find the value. Today I will stop here. In my next video I will briefly discuss complex integration and application of complex integration briefly. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.